So I'm going to show you actual proof. Again, using a thing that you don't have to take my word for anything. You only have to believe your own eyes. If you know anybody anywhere who is a significant distance east or west of you, do a simple experiment where you hang a yardstick. You suspend it so it points straight down on a sunny day, and you hang from the ground and you see how long its shadow is. And you mark the shadow on the ground and you measure it. And let's say this guy here says, all right, the shadow is about 1.5 feet long. If that's a yard, maybe the shadow is 1.5 feet long. And then you call somebody significantly east or west of you, somebody who can see the sun at the same time, and you say, first of all, how far away are you from me? Second of all, do the same experiment. Hold up a yardstick and hold it so it's hanging straight down, right at ground level, measure the length of the shadow. So let's say this guy says, well, I have a 4-foot shadow. Well, I have a 1.5 foot shadow. Now, if you do the simple geometry, you don't need to use sines and cosines and all that equation. I mean, you can use them if you know how to, or you can do it the old way. You can triangulate and find the exact height of the sun based on this distance, how far apart you are from your buddy on the phone, and based on the length of the shadows, you can make a triangle, no matter how long these shadows are. Now, I'm going to do the easiest possible example that makes the math really damn simple. It's a version of that, but it's as easy as you can get. Now, the math gets really, really, really easy if you're at the equator. If you're north or south of the equator, then you have to take into account the fact that it's, you know, you're looking a little bit south down at the sun because it won't be all the way overhead. But I'm going to use the example of Maine. Let's say you're in Maine, and you say, all right, right about now, I'm going to call my buddy when the sun's directly overhead. And it isn't really directly overhead, it's south, but it's overhead as far as east and west. It's only south. It's at the top of its arch in the sky. And you're in Maine, and you say, okay, my shadow is as little as it gets. It's not at all, there's no shadow going east or west of that. I'm going to call my buddy in Death Valley, California, because that's about 3,000 miles. It's a little short of that, but close enough. We're going to do the simplest math and say, hey, buddy, would you mind doing this experiment where you hold up a yardstick and measure the shadow it makes? And your buddy in Death Valley, California, while you're doing this live on the phone, will say, well, I measure it, and as it happens, my yardstick casts a shadow that's about a yard long. Now, I'm going to use rough numbers here. The accuracy doesn't even particularly matter. You know, we can have a 50% margin of error, and it would still be good, and we're much better than that. So your buddy in California says, my shadow is a yard long, and you're saying, I don't have a shadow at all. That makes the math ridiculously easy, because if this distance from you to him is 3,000 miles, and the sun is directly over you, because you're pointing up to it, and his shadow is 3 feet long, that's a perfect 45-degree angle. That means from his shadow, he's looking at 45 degrees up to the sun, you're looking straight up to the sun, and therefore those two lines determine where the sun is. And like I said, this is the simplest the math gets. If that's 3,000 miles, and this is a 45-degree angle, then this is 3,000 miles. Which means if the Earth is flat, you and your flat Earth buddy just proved that the sun is 3,000 miles off the ground. Cool, nifty, spiffy, works fine. Excellent, good job, very scientific of you. You can do this yourself, it's really frickin' easy. Then you call your buddy in Hawaii. Here's another 3,000 miles, not quite that far, but close enough for our measurements here. And you ask your buddy in Hawaii, hey, buddy in Hawaii, can you do this experiment? Hold up a yardstick and measure its shadow and say, but wait, we flat earthers are so in the know and so understanding, we're going to tell you what you're going to find. You're going to find that you're looking at the sun at about a 20-some degree angle in the sky, and your shadow will be about 6 feet long. Because for you it was 0, for him it was 3 feet, for him it'll be about 6 feet. It'll cut this angle in half. It won't be that sharp. It'll be a 20-some degree angle in the sky. And you say, this is awesome. We're going to tell you ahead of time, we the understanders of the flat earth, what you will find when you do this experiment. And your buddy in Hawaii will say, sorry, dude, the sun is at the horizon. It's at 0 degrees. It's just coming up over the ocean right now. My shadow is infinite. It goes forever. It goes all the way off the island because the sun is straight across from me. That is called a proof that the earth is not flat. Because if these people were in a straight line, and this is 3,000 miles and this is 3,000 miles, this guy would see the sun there. He doesn't see the sun there. Call him and ask if he sees the sun there. He won't. He will see it over there, which doesn't work on this model. This picture is false because this line and this line and this line don't intersect anywhere. If you just ask the Hawaii guy and this guy, oh, where's the sun? He'd say, it's sitting on top of your frickin' head because you're looking up and I'm looking straight across. The sun is basically your hat. And if you talk to this guy and this guy, their lines don't intersect at all. It's like, well, that's utterly impossible. You're seeing it up in the sky. I'm seeing it below you. It doesn't freaking work. That's called a proof that the earth is not flat. So what actually explains what we see when we do this experiment? When you do this experiment with your buddies and your cell phones and your yardsticks. Golly gee, here's the guy in Maine who points straight up to look at the sun, well, a little bit south, but as far as east and west is concerned, straight up. Here's the guy in Death Valley, California who points, here's how he's standing, he points at a 45-degree angle to a sun really, really, really frickin' far away in that direction. Now the Hawaii works. He's pointing flat to the horizon. And it's really dang far away. This model actually matches what you see when you walk out your frickin' door and look in the sky. The flat earth model doesn't. It is provably false. Now, we're not done there. Because you, on a daily basis, have more evidence that the earth is not frickin' flat. For this, I'm going to throw this around a little bit. Yeah-dee-dee-dee-dee. And I'm going to bring you up. Oh, first of all, so you can see this, this is my flat earth map. Wait, let me move this so you can see more of it. Here's my flat earth map. This is what flat earthers think the earth is shaped like. Now, I just scribbled it, obviously. The South Pole is actually this humongous ring that goes around everything. North Pole is in the middle. Here's South America, North America, Africa. You can tell how much effort I put into these drawings. Here's the equator. Now, according to them, the sun is going around in a circle over the equator about 3,000 miles up. Now, depending on when they do their calculations, they argue with each other about how high up it is, but I just had you do the proof of the simple math version that if it's a flat earth, it's 3,000 miles off the ground. Okay, so here we have the flat earth model. Here's the outside, here's the equator, so this is what they say the sun goes around. La-dee-dee, la-da-dee-dee-dee-dee-dee, la-dee-dee. Here is your view. Here's your view. I'm putting you at the tip of South America. See this sun? This is about the height it would be at. Here we are. Ta-da. It's at the equator's right here. This is about 3,000 miles up. Here's what the sun would do. Do you notice anything suspicious? Do you notice two suspicious things? Here's what the sun would do if you were at the tip of South America on a flat planet looking up. Number one suspicious thing that's kind of hard to miss, the sun doesn't ever set. If the world was flat, at no point would the sun ever set for anybody anywhere on the whole frickin' planet. Is that what you observe when you go out and see the sun? Item number two. Do these look the same size? Guess what? They are the same size. Do they look the same size? No. Because if something is twice as far away from you, it looks half as big. And if you remember the drawing I did of the three people in Maine and California and Hawaii, the guy in Hawaii is looking over 6,000 miles to the sun, where the guy with the sun straight over him is only looking at 3. Does the sun get less than half as big at the end of the day? Nope. and you can take pictures and you can see, oh, it's the same frickin' shape, it's the same frickin' size the whole day. Do these look like the same size? Because guess what? They freaking are. Does this look like what the sun does in the sky? No, because it frickin' doesn't. Now, it's even better if you're on the equator. And by the way, as it happens, the Acapulco is close enough to the equator to be a great example. If you're on the equator, you will see the sun directly overhead. It will never get closer to the horizon than this, ever, according to the flat Earth model. Which means you'll see a huge sun overhead, and then you'll see it go way in the distance over here and get really little, and then come back and go over your head. It will never get closer to the horizon than this, and it'll get really damn small. If you're in Acapulco, is that what you see? No, it's not. You see a sun that looks the same frickin' size the whole time, come up in the east, go straight over you, and go down in the west.